Let's explore how to add and subtract two rational expressions. Let's go back again to rational numbers. For example, let's add these two rational numbers together. 9/10 plus 4/5. Many of us may feel that we should just be able to add the numerators, 9 plus 4, the denominators, 10 plus 5, and that should be our answer, which would be 13 over 15. Is this valid? Can we do it like this? Is this a rule? Turns out the answer is no. The answer here is not 13 over 15. As you can see, if you think of this, the 9/10, so you have 9/10 one candy bar and 4/5 of another candy bar. How many candy bars do you have in total? Well, 90% of one, 80% of another, so the sum will be more than one, will be greater than one candy bar. So to ask yourselves whether the sum is 13 over 15, the answer is clearly no. 13 over 15 would be less than one candy bar. So you cannot add rational numbers in this way. What you can do to add these two rational numbers is come up with a common denominator. Let's look at 4/5. Let's express 4/5 as a rational number having denominator 10. How do we do that? Well, 5 times what is 10? 5 times 2. 5 times 2 is 10. So we do the same to the numerator. 4 times 2, 8. 4/5 is the same as 8/10. We can make that substitution. And now that we have a common denominator, you can just keep that common denominator, add up the numerators, and you get 17 over 10. And it turns out, yes, we would have 17/10 of a candy bar, or one candy bar and 7/10 of a second one. Now let's subtract. Let's subtract two rational expressions. Let's subtract these two rational expressions. Let's go back and look again. Let's go back and look at rational numbers. How do we subtract these two? 7/15 minus 5/12. Well, we saw before that we needed a common denominator. Since well, in many of these problems, we need our answer, our final answer, in factored form. It is optimal to use the least common multiple. Let's use this common denominator. What is the LCM of 15 and 12? Let's write down 15 and 12. What's the LCM? Let's first write out the common multiples, and then let's pick out the least common multiple. Common multiples are 60, 120, 180, 240, 300, etc. And it turns out that the least common multiple is 60. How do we compute that, though? How do we actually compute the least common multiple? Let's see. We can determine the least common multiple from the prime factorizations. Complete prime factorization of 15 is 3 times 5 of 12, 3 times 2 squared. So how do we use this to find the least common multiple? Well, the least common multiple, of course, which is 60. Well, the least common multiple will be a multiple of every factor of our two numbers. So it has to be divisible by each of the prime numbers that occur in a factorization. And we write up all the prime numbers, 3, 5, and 2. And now what remains are the exponents. What is the exponent of 3 in the LCM? What is the exponent of 5? And what is the exponent of 2? Many of you are tempted to write, let's see, what are the exponents in the factorizations? This is 1, this is 1, this is 1, and of course this was 2. So for 3, many of you would be tempted to write 1 plus 1 is 2, so this should be 2 up here. However, this turns out to be 1. This is 1, and this is 2. Why is the exponent of 3 equal to 1? not the sum of the exponents and the factorizations. It is the greatest or the maximum exponent that occurs for 3. So this is 1. The greatest exponent. The largest between 1 and 1 is 1. So the LCM is 3 times 5 times 4. This is 60. Okay, so we want to take 7/15 and write it as a fraction with denominator 60. Now, how do you go from 15 to 60? 15 times something equals 60. What is it? Well, it's 4. So 15 times 4. And if you multiply the denominator by 4, you must multiply the numerator by 4 to balance, or to keep the rational number equivalent. So you get 28 over 60. 7/15 is the same as 28 over 60. And our other number, 5/12, you see that 60 is 12 times 5. So we do multiplication by 5 in the denominator. Do the same in the numerator. You get 25 over 60. So the problem, the subtraction of rational numbers problem, becomes one with a common denominator. And again, put your answer in lowest terms, 1 over 20. So it's the same approach here. We first must find a common denominator. Let's compute the LCM of the two denominators. We factor each of the individual denominators. This x squared plus 8x plus 7 factors as, let's see, a pair of numbers whose product is 7 and whose sum is 8. Be plus 1 and plus 7. And right here, this is already factored completely. So the LCM is spread of all the prime polynomials that occur. X plus 1, we have x plus 7. And now the greatest exponent that occurs for x plus 1, you're choosing between 1 and 2. Greatest is 2. You don't add them. Take the greatest. It's 2. And here, this is 1. So now we need to write this fraction, this rational expression. Can we factor the denominator? We need to write it with the least common denominator. So we need to multiply that by, let's write it in green. To get to the LCM, we need to multiply it by x plus 1. So we multiply the top by the same. This turns out to be, again, this is the LCM on the bottom. For the other fraction, x plus 2 over x plus 1 squared, we need to multiply the denominator by x plus 7. Multiply the top by the same. Don't forget this step. And now you have it expressed with the LCM as the denominator. Okay, so now let's write this out. So here is our subtraction problem, now with a common denominator. So we keep this common denominator, and we subtract the two numerators. And we may be tempted here to cancel the x plus 1. Let's write this down. This is not a rule. You cannot cancel factors in a term. Cancel the x plus 1. You cannot cancel those. Similarly, you cannot cancel the x plus 7 on the bottom with the x plus 7 on top. You need the top to be written as a product. Here it's a difference of two terms. That's when you can cancel. And you can cancel common factors. So we can't cancel right now, but to simplify this, we should expand out the numerator. Let's see what we get. This is 2x squared, we FOIL, minus 3x plus 2x minus 3 minus, let's keep this minus sign in front. First, let's multiply the two binomials, x squared plus 7x plus 2x plus 14. Okay, let's go from here. Okay, we need to distribute the minus sign in the numerator. Let's first simplify the terms out in front. This becomes 2x squared minus x minus 3. And now we distribute the minus sign. Essentially, we simply change the sign of each term in the brackets. Minus x squared minus 7x minus 2x minus 14. I'm not going to expand out the denominator. I'm not going to multiply out the denominator. Because we want to see if we can cancel any common factors. So first we need to write the top as a product of factors. The top simplifies to x squared minus 10x minus 17. Does this trinomial on top factor? We're going to find two numbers whose product is minus 17 and whose sum is minus 10. Can't find a pair of integers like that. So it is prime. No common factors exist. And this is our final answer. It's in factored form as they wanted, and it's completely simplified.